About a topic in maths itself, it's a branch of maths. Kalasa would be very interested in what I have to say right now. My topic is calculus. So, calculus is the study of continuous change, and as it is, calculus has two major branches. There is differential and integral calculus. So differential calculus concerns rate and slope curves, while integral calculus deals with the relation of quantities and the areas under and between curves. Calculus in today's world has a lot of real world applications, such as physics, economics, and engineering. See, calculus is a gateway to other more advanced areas of mathematics, such as with there being other theories concerning calculus, such as Ricci calculus, proportional calculus, and process calculus. The founding fathers of calculus were Isaac Newton and Gottfried Leibniz, who published the works of calculus independent of each other. Although there was somewhat of a clash between the both of them about who discovered calculus independent of who. But then everything got sorted out. They discovered calculus independent of each other, and there's also been backdating of calculus back to the 13th century, which led to integral calculus. But the ideas that were brought forward in the 13th century were not brought to light in a rigorous and systematic way. From the age of Euclides, who used the method of exhaustion to find the areas and volumes. So basically, what he did, there was a method of exhaustion, and so using logical reasoning, you keep on eliminating values. For example, even Archimedes did a similar thing by he found the area of a circle using a polygon, using the edges of a polygon. There have been many such methods, and also in the medieval period, when the Arabic mathematician Al-Hasan derived a formula for the sum of the fourth powers. Calculus has endured the unequal test of time till recently, when it was defined using modern mathematical methods. Leibniz is the one who introduced dx and dy to denote infinitesimal increments in the independent and dependent variables. Also the one who introduced the integral function, which is an extended s. You guys know integral function, right? Which is meant to say the sum of. The product rule, on the other hand, the chain rule and the notations of higher derivatives and analytic functions were developed by Newton. And just a side note, Newton was very sloppy while doing calculus. He was very sloppy to the approach of the rigorousness of calculus. And right now I'm going to talk about the application of calculus. So the application of calculus, differential calculus in particular, includes the computation of velocities and acceleration, the slope of a curve, and optimizations. Application of integral calculus includes the computation of area, volume, work, and pressure. So it has a lot of real world applications, also a lot of applications in physics. Integral calculus is the study of definition, properties, and applications of two related concepts, which is the definite integral and the indefinite integral. See, the process of finding the value of an integral is called integration. So, and also chemistry makes use of physics. Chemistry makes use of calculus in determining reaction rates and radioactive decay. Physics makes particular use of calculus, and the formula F is equal to ma, which was derived by Newton, was in fact a calculus derivation. And with this, I would like to bring the speech to a close. So, Kalasa, do you like it?
Thank you, Surya.